Hello, my name is Anand Shetler, and this is my arc length project for Calculus AB with Dr. Heitzman. The path that I chose is part of the Glenrock Duck Pond. This is a biking path in the park. So I plotted my path using the draw a line, add line or shape tool, and I added a marker at the start of my path. So I plotted about 12 or so points along my path. And using this path, I found a bunch of points along the path using the measure distances and areas tools. I did this by using a line here as my x-axis and a line here as my y-axis, which I now erased to better show where the path is, and I used the marker as my origin. So to find each point, I clicked on the marker to use that as my origin, drew a straight line along where my x-axis is, clicked again to make a point, and then extended out a perpendicular line to where it would intersect the path. Then I used this new value, for example 61 right here, and subtracted the old value of about 45 to find the y coordinate of that point, and I used the original value as my x. And since I was drawing a line across the top of the graph, I used the negative values of the y coordinates as my values. So after doing that, I found my point, which would be this, and I found them in intervals of 18 feet, just so that I would have 12 points, each of them equally spaced and taking up the length of the entire path. So after doing that, I plotted my points in the Desmos online calculator right here, and you can see them as the green points on the graph. After doing this, I determined that the points best resembled a cubic function, so I needed to use a cubic regression to find the proper function for these points. To do so, I used the Desmos built-in cubic regression function, and this is the function that I got. So as you can see, it resembles the points plotted on the graph pretty clearly, and this is the function that I found. So after that, I needed to find the arc length of the path. So I used the arc length formula right here. I just put it in Desmos right here, from 0 to 198 feet, which is where the path that I drew ends. And I used the cubic function that I found as my function, found the derivative of that, and just plugged it into the equation. And when I did that, I found the value of my arc is about 218 feet, and the value given in Google Maps is 214 feet, which is pretty close. So after finding that, I calculated the percent error, which in my case, if you don't round it to 218 feet and leave it as 217.91, etc. feet, then the percent error is about 1.828%, which is pretty close to the actual value. So yeah.